Hello everyone, this is Sravanthi, Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss the topics are types of hardness. In this we'll discuss temporary and permanent hardness and expression in units of hardness. So now we'll discuss introduction about this water. So already we know that water is a natural gift on the earth. It is most essential for human beings, animals, plants. So human beings use water for drinking, cooking, cleaning, washing, etc. Everything, everywhere we are using water. So without water, we can't live on the earth. We can't survive without water. So that's why water is also called as universal solvent. So water is also called as universal solvent. So chemically, so water consists of two hydrogen atom and one oxygen atom. See here, one oxygen and two hydrogen atoms. So chemically, water consists of two atoms of hydrogen and one atom of oxygen. Hence, the molecular formula of this water is H2O. So generally, pure water, there is no color, no taste, and doesn't smell of anything. And water exists in nature three different forms. One is solid, liquid, and gaseous forms. So water exists in three forms in the earth. So solid form of water is ice. Solid form of water is ice. And liquid form of water is in the form of like ocean, rivers, lakes, or rainwater, etc. And gaseous form is water vapor. So water available in nature in three different forms: solid, liquid, and gaseous form. So which type of impurity is present in water? Generally in natural water usually contaminated by three different types of impurities. Or impurities are classified into three different types. First one is physical impurities, chemical impurities, and biological impurities. So the natural water is usually contaminated by three different types of impurities: physical impurities, chemical impurities, and biological impurities. So first we'll discuss physical impurities. Physical impurities means in this we'll discuss color, turbidity, taste, odor, etc. These all are physical impurities. So color means generally water is having no color. But in this, it is mainly caused by presence of metallic substances like salts present in water. That's why it produce color to water. This is one of the physical impurity. Next, turbidity. It is mainly due to the presence of colloidal impurities or insoluble substances like clay, sludge, or any of the microorganisms present in this type of impurities. Also, one of the example of physical impurities. Next, taste. So generally, water is in this water is presence of dissolved minerals present in water. Generally, it produces good taste. But bitter taste it causes, it is due to the presence of iron or aluminum or sulfates or any other chemicals present in this water. That's why it produces a bitter taste to water. And sometimes it is soap taste. Soap taste mainly due to the presence of a large amount of sodium bicarbonate. Large amount of sodium bicarbonate present in water. That's why it produces soap taste or sometimes bitter taste. And next, odor. So generally in water, it is if in case it is bad odor present in this, that means undesirable salts present in this water. We cannot use for this type of water for domestic as well as industrial purpose. So these are the physical impurities present in this natural water, which contaminates the natural water. Next, we'll discuss chemical impurities. So there are two types of chemical impurities: inorganic chemical impurities, organic chemical impurities. So inorganic chemical impurities means like some cations or anions present in water. So cations means aluminum, calcium, magnesium, zinc, copper, sodium, potassium, etc. So all is containing inorganic cations. And anions means chloride, sulfates, nitrates, bicarbonates, fluorides, etc. present in water. These are called inorganic anions. So inorganic impurities or inorganic chemicals like cations or anions present in water. This is the best example of chemical impurities present in water. It contaminates the water. And third type is biological impurities. So in this biological impurities are algae, or pathogenic bacteria, or fungi, or virus, or pathogens, parasites, worms, etc. All the biological impurities present in water. So these three types of impurities present in water will contaminate the natural water. One is the physical impurities, and second one is the chemical impurities, and third one is biological impurities. So it contaminates the water. So now let's discuss types of water. Generally, there are two types of water: hard water, soft water. So first we'll discuss hard water. So what is the meaning of hard water? So when we treat it with soap, it doesn't produce lather. Is called hard water. Why this water doesn't produce lather? Because its presence of calcium, magnesium ions of bicarbonates, chlorides, sulfates that are present in water. That's why when we treat it with soap, it doesn't produce the lather. This type of water is called hard water. For example, here see, so the water which did not produce lather with soap is called hard water. It is mainly caused by presence of dissolved salts of bicarbonates, sulfates, chlorides of calcium and magnesium salts. Calcium and magnesium salts present in water. So when we treat it with soap to this hot water, hot water means it's containing calcium, magnesium, bicarbonate, chloride, sulfates, etc. So when we treat it with soap, it doesn't produce lather because, for example, soap. Soap means what is the chemical name of soap? It is a sodium or potassium salts of higher fatty acids such as stearic acid or oleic acid. For example, here you are taking stearic acid C17H35COOH stearic acid formula. So soap is the sodium or potassium salts of high molecular weight fatty acids such as stearic acid or oleic acid. So where the soap is mixed with hard water, that means it containing calcium or magnesium combinations present in water. So when we treat it with soap, this water, it produces calcium stearate or magnesium stearate insoluble precipitate. It forms calcium stearate or magnesium stearate insoluble precipitates are formed. So that's why when we treat it with soap, this water doesn't produce lather. This is the main reason. For example, here see the reaction. So this is sodium stearate, the soap formula. So when we treat it with soap with this hot water, so hot water means it presents calcium or magnesium ions. So here I am taking calcium present in hot water. So when we treat it with this soap, so this hardness causing ions react with soap then form calcium stearate. If in case in this water magnesium ions present, it produces magnesium stearate. These are insoluble precipitates. So that's why it doesn't produce lather. This is a soap reaction with hot water. Now see this image here. So 0 to 60 ppm. That means it considered as soft water. The hardness is 0 to 60 ppm. It considered as soft water. For example, 60 to 120. It considered as moderate hard water. For example, 120 to 180 combination. 120 to 180 ppm of hardness. This water considered as hard water. And 180 plus, the above 180 ppm. It considered as very hard water. So we can divide this hardness based on this hardness. We can divide 0 to 60 soft water, 60 to 120 moderate hard water, 120 to 180 hard water, and 180 above or above 180 it considered as very hard water. So based on hardness, hard water is classified into this type. And next see here. So hard water means it consists of calcium, magnesium, bicarbonate, chloride, sulfates, etc. present in water. Here starting these bicarbonates, all these are present in this water, hardness causing ions. So due to this hardness, it forms precipitates. If in case hardness causing ions present in this water, it forms precipitates. Next second type is soft water. So what is soft water? When we treat it with soap, it produces lather. When we treat it with soap, it produces lather is called soft water, but it doesn't produce lather is called hard water. So the water sample which gives or produce lather with soap is called soft water. So soft water does not contains dissolved salts of calcium and magnesium salts. Soft water doesn't containing any calcium, magnesium, hardness causing salts. So that's why when we treat it with soap, it produce lather. So the what is the main advantages of this soft water? Less fuel required and time also very less required for cooking in soft water. So when soap is mixed with soft water, it produces lather because due to the stearic acid and sodium stearate. For example here, sodium stearate, soap formula. When we treat it with soft water means absence of all this calcium, magnesium, hardness causing ions. So that's why you are writing H2O, absence of all this hardness causing ions. So when we treat it with soap with soft water, it produces stearic acid. So the stearic acid and sodium stearate combination to produce lather. So when we mix it with when we treat it with soap, with soft water, it produces lather due to the combination of stearic acid and sodium stearate. That's why it produces lather. Next, types of hardness of water. So there are two types of hardness. One is temporary hardness and the one is permanent hardness. So temporary hardness of water. Temporary hardness means it's present. Generally, total hardness means its presence of calcium, magnesium, bicarbonates, chlorides, sulfates, etc. But only temporary hardness means it is mainly caused by presence of calcium, magnesium, bicarbonate present in water. The presence of calcium, magnesium, bicarbonates in water, it considers as temporary hot water. So how can you remove this temporary hardness? By boiling. This temporary hardness we can remove by boiling. So there are two types of hardness of water, temporary hardness, permanent hardness. Temporary hardness means its presence of calcium, magnesium, bicarbonates in water. So it can be removed by boiling process. This temporary hardness we can remove by boiling process. So what is the reactions takes place during boiling? How can we remove this temporary hardness present in water? So when we boil water, starting this bicarbonates present in water, these are soluble in water. We cannot see starting without boiling. So during boiling process, the soluble bicarbonates converted into insoluble carbonates, insoluble precipitates. So it can be removed by filtration. So see here, when we boil the water, so soluble salts of calcium bicarbonates or magnesium bicarbonate present in water, it can be converted into during boiling process calcium carbonate or magnesium hydroxide insoluble precipitates. Starting these are soluble in water. So during after boiling or during boiling process, these soluble precipitates converted into insoluble precipitates. So after filtration, the water we get is soft water. What we get that water is called soft water after during boiling and after completion filtration process we get soft water. So in this way we have to remove the temporary hardness by boiling process. So what are the reactions takes place in this temporary hardness? So temporary hardness we can remove by boiling process. So during boiling process, for example here, see the reaction. For example here, we are taking water in steel bowl or during heating process, we observe heaters. So for example here, we are taking water in this bowl. So during heating process, a white color precipitate is formed in the edges of this bowl. That is called calcium magnesium bicarbonates present in water. So starting these bicarbonates present in water, these are soluble in water. You can't see this bicarbonates present in water. So during heating process, this calcium bicarbonates or magnesium bicarbonate, during heating, if in case this bicarbonate present in water, these soluble bicarbonates converted into insoluble calcium carbonate. And next here also magnesium bicarbonate if in case present in water during heating process, starting these are soluble. So during heating process these are converted into insoluble precipitates magnesium hydroxide. So it can be removed by filtration. Finally, we'll get soft water. We can remove temporary hardness by boiling process. Now, second type of hardness is permanent hardness. Permanent hardness. So permanent hardness means the hard water contains except bicarbonates. That means calcium, magnesium ions of chloride, sulfates present in water except bicarbonates remaining gone is called permanent hard water. That means that water containing calcium, magnesium chloride, sulfates present in water. This water is considered as permanent hot water. So this permanent hot water we cannot remove by boiling. That's why this is called permanent hardness. Permanent hot water we cannot remove by boiling. So how can we remove this permanent hardness? Generally, this permanent hardness is we can remove by using washing soda. Using washing soda or adding washing soda, or some other methods are like ion exchange method, geolite process. So many methods employed for this to remove permanent hardness causing ions, but we cannot remove by boiling this type of hardness. So for example here, see here, we can remove this permanent hardness by treating with this water with treating the water with washing soda. Washing soda means the formula is sodium carbonate. So when we treat it with sodium carbonate or washing soda, so these insoluble carbonates are formed. Insoluble carbonates are formed when reacts with this washing soda. So here, this washing soda, that means sodium carbonate, reacts with water. If in case in this permanent hard water is present, that means calcium chlorides or magnesium chlorides or calcium sulfate or magnesium sulfate present. These are the permanent hardness causing salts. So if in case these permanent hardness causing salts present in water, when we treat it with soda like sodium carbonate here formula, washing soda. So in this case, it's starting this calcium chlorides or calcium magnesium combinations of chloride or sulfate present in water. These are soluble in water. So when we treat it with this washing soda, these permanent hardness causing salts, soluble hardness causing salts converted into insoluble precipitates. Like for example here, calcium chloride present in water. This is a permanent hardness causing salt. So how can we remove this one? When treated with sodium carbonate, that is called washing soda. So during this, these are soluble starting in this water. During treated with the sodium carbonate, it converted into calcium carbonate insoluble precipitate. So it can be removed by filtration process. Finally, you get soft water. That means hot water converted into soft water. Now let's discuss expression of hardness in terms of CaCO3 equivalent. Because all the hardness causing salts, that means in water it containing different types of hardness causing salts, different percentages available in water. For example, calcium bicarbonate or magnesium bicarbonate, calcium magnesium chlorides, calcium magnesium sulfates. So all these hardness causing salts, different percentages available in water. So how much amount of this hardness causing ions present in water? So it can be calculated. All these hardness causing salts converted into CaCO3 equivalent terms. So that means all these hardness causing salts converted into CaCO3 equivalent terms, because what is the reason why you have to prepare only prefer this calcium carbonate? What is the reason this calcium carbonate chosen as a standard? Because this calcium carbonate molecular weight is 100 and equivalent weight is 50, and it is highly insoluble in water. So it makes calculation is very easy. That's why we prefer calcium carbonate. All the hardness causing salts we can convert it into CaCO3 equivalent terms, because one is reason is calcium carbonate molecular weight is 100 and equivalent weight is 50, and it is highly insoluble in water. So the water analysis it can be simplified. That means it makes calculation is very easy. That's why all the hardness causing ions we can convert it into CaCO3 equivalent terms. So how can we convert this all hardness causing ions in CaCO3 equivalent terms? So this is a formula you are using to for conversion. So what is the formula? Expression of hardness in terms of CaCO3 equivalent. It's equal amount of hardness causing salt by molecular weight of hardness causing salt into 100 into 100. Here amount of hardness causing salt means, for example, 50 ppm of magnesium sulfate present in water. 50 ppm of magnesium sulfate present in water. So how much amount of hardness causing salt, that means magnesium sulfate present in water? 50%. So 50 percentage of magnesium sulfate present in water, that is the amount of hardness causing salt by molecular weight of magnesium sulfate into 100. 100 is the molecular weight of CaCO3. So by using this formula, we have to calculate the hardness causing salt, how much amount of hardness causing salt present in this water. So that purpose, first we converted into CaCO3 equivalent terms. Next, most important, units of hardness. So generally 4 types of units are present, hardness measured in 4 types of units: ppm, parts per million, milligram per liter, degree of Clerk, degree of French. There are 4 units measured in hardness, or hardness measured in 4 types of units: parts per million, milligram per liter, degree of Clerk, degree of French. So first one is parts per million, ppm shortcut. So what is the meaning of ppm? So the number of parts of calcium carbonate equivalent hardness in 10 to the power 6 parts of water. So what is the meaning? 1 ppm equal 1 part of CaCO3 equivalent hardness in 10 to the power 6 parts of water. So for example here, okay, 50 ppm of 50 ppm of calcium bicarbonate present in water. So what is the meaning? 50 parts of calcium bicarbonate converted into CaCO3 equivalent terms, because always hardness causing salts converted into CaCO3 equivalent terms. Why we have to prepare CaCO3? Because its molecular weight is 100, equivalent weight is 50, and it is highly insoluble in water. So that's why we prefer CaCO3. So all the hardness causing salts converted into CaCO3. So in this case, it makes calculation is very easy. So here parts per million means all the hardness causing salts. For example, here 50 ppm of calcium bicarbonate. So 50 parts of calcium bicarbonate first converted into CaCO3 equivalent terms present in 10 to the power 6 parts of water. So for example, here you are taking 1 ppm and 1 part of, for example, calcium bicarbonate. So 1 part of calcium bicarbonate converted into hardness causing terms, that means CaCO3 equivalent present in 10 to the power 6 parts of water is called 1 ppm. So number of parts of calcium carbonate equivalent hardness in 10 to the power 6 parts of water is called ppm. Next we'll discuss milligram per liter. So number of milligrams of calcium carbonate equivalent hardness in 1 liter of water. In 1 liter of water. So what is the meaning? Same here. The number of milligrams of hardness causing salt converted into CaCO3 equivalent terms. What is the reason? Just now discussed already. Because it makes calculation is very easy or simplified. So that's why the number of milligrams of CaCO3 equivalent hardness is present in 1 liter of water. For example, 1 milligram per liter is equal 1 milligram of hardness causing salt converted into CaCO3 equivalent hardness in 1 liter of the water. But 1 liter of the water, its conversion is, it's equal 1 liter equal, generally we know that already, 1 kg. So 1 kg equal how many grams? 1000 grams. And it's equal how many milligrams? 10 to the power 6 milligrams. 10 to the power 6 means here ppm is 10 to the power 6 parts. So 10 to the power 6 milligrams are equal 10 to the power 6 parts. That means it's equal 1 ppm. So mathematically, this ppm and milligram per liter both are equal. So mathematically 1 ppm equal 1 milligram per liter, both are equal. So now let's discuss Clerk's degree. So what is the meaning of Clerk's degree? So number of parts of calcium carbonate equivalent hardness presence in 70,000 parts of water. So what is that meaning here? For example, one Clerk degree. It's equal to one part of hardness causing salt. Any hardness causing salt present in water. One part of hardness causing salt which are present in water that can be converted into CaCO3 equivalent terms. Next, it is present in 70,000 parts of water. It's considered as 1 Clerk degree. The number of parts of hardness causing salts converted into CaCO3 equivalent terms present in 70,000 parts of water. And last one is degree of French. Degree of French. So what is the meaning of degree of French? Number of parts of hardness causing salts converted into CaCO3 equivalent hardness present in 10 to the power 5 parts of water. Present in 10 to the power 5 parts of water. For example, 1 French degree equaled 1 part of CaCO3 equivalent hardness present per 10 to the power 6 parts of water. So in this units of hardness I discussed already. First one is ppm, milligram per liter, degree of Clerk, degree of French. So all these 4 units, first are any hardness causing salts which are present in water, all are converted into CaCO3 equivalent terms. After that, if in case it is present in 10 to the power 6 parts of water, is called ppm. It's present in 1 liter of water, it considered as milligram per liter. If it's present in 70,000 parts of water, that means it's considered as Clerk's degree. If in case it's present in 10 to the power 5 parts of water is considered as French degree. So mathematically ppm and milligram per liter both are equal. And what is the relation between all these units? Relationship between all these units. So what is this is the basic relation between all these 4 units. So 1 ppm equal 1 milligram per liter and it's equal 0.07 Clerk degree and it's equal 0.1 French degree. It's the basic relationship between all the 4 units. 1 ppm equal 1 milligram per liter and it's equal 0.07 Clerk degree and it's equal 0.1 French degree. So see here, what is the relationship between all these units? Here, just now discussed already, 1 ppm equal 1 milligram per liter and it's equal 0.1 French degree and it's equal 0.07 Clerk degree. So in the same way, 1 milligram per liter, so what is the relation between? So already we know that ppm equal milligram per liter, both are equal. So same relationship, 1 milligram per liter equal 1 ppm and it's equal 0.07 Clerk degree and 0.1 French degree. In the same way, 1 Clerk degree equal how many ppms? So 1 Clerk degree equal, for example here, 1.433 French degrees, 14.3 ppm and in the same 14.3 milligram per liter. So see here, 1 French degree equal how many milligram per liter? 10 milligram per liter. So 10 ppm and how many Clerk's degrees? 1 French degree equal 0.7 Clerk degrees. So this is the relationship between all the 4 units of hardness. So general hardness causing ions and molecular weights of these hardness causing ions is the most important for calculation problematic purpose. So generally in water it contains calcium, magnesium, bicarbonates, chlorides, sulfate, nitrates, etc. So calcium bicarbonate, its molecular weight is 162, magnesium bicarbonate 146, magnesium nitrate 148, magnesium sulfate 120, magnesium carbonate 84, magnesium chloride 95, calcium nitrate 164, calcium carbonate 100, calcium sulfate 136. This calcium carbonate molecular weight is 100. So it makes calculation is very easy. That's why hardness causing salts we can convert it into first CaCO3 equivalent terms by using that formula. The weight of hardness causing salt by molecular weight of hardness causing salt into 100. And its calcium chloride molecular weight is 111, calcium 40, magnesium 20. So all these hardness causing salts molecular weight is important for numerical calculation purpose. So for example, sample numerical we'll discuss. So for example here, sample of water is found to be contains following dissolved salts in milligram per liter. Units are milligram per liter, they are given in this problem. So like which type of salts present in this water? Magnesium bicarbonate is equal to 73 and calcium chloride is 111 and calcium bicarbonate is 81, magnesium sulfate is 40 and magnesium chloride is 95. So calculate the temporary, permanent and total hardness. So temporary hardness causing salts means just we discussed already discussed calcium or magnesium bicarbonates present in water, that hardness is considered as temporary hardness. So permanent hardness means calcium, magnesium, chloride, sulfates present in water. So that water considered as permanent hardness. So total hardness means temporary hardness and permanent hardness. Total hardness. It is called total hardness. So how can we calculate the temporary, permanent and total hardness? For example, here its present salts are magnesium bicarbonates, calcium chloride, calcium bicarbonate, magnesium sulfate and magnesium chloride. So how much amount of hardness present in this water and it's given in this data. So magnesium bicarbonate is 73, calcium chloride is 111, calcium bicarbonate is 81 and magnesium sulfate is 40 and magnesium chloride is 95. So this much amount of this hardness causing source present in water, these are given in this data. So what is the molecular weights of hardness causing salts? So magnesium bicarbonate molecular weight is 146, calcium chloride is 111, calcium bicarbonate molecular weight is 162 and magnesium sulfate molecular weight is 120 and magnesium chloride molecular weight is 95. So first all these hardness causing salts, these are available in this water, different amounts, different percentages in this water. So all these hardness causing salts first converted into CaCO3 equivalent terms because it makes calculation is easy, simplifies the calculation. So what is the formula we are using in this purpose conversion of amount of equivalent hardness into CaCO3 equivalent terms? So it's equal weight of hardness causing salt by molecular weight of hardness causing salt into 100. So here weight of magnesium bicarbonate hardness causing salt is 73 and molecular weight is 146 into 100 is equal 50. For example, in the same way, calcium chloride weight is 111, molecular weight also 111 into 100. And calcium bicarbonate weight is 81 present in this data and molecular weight is 162 into 100 is equal 50. And magnesium sulfate, its weight is 40 and molecular weight is 120 into 100. Here 100 is the molecular weight of CaCO3. So we have to convert it in the CaCO3 equivalent term. That's why we are taking this formula. So its value is 33.3. And finally, magnesium chloride, its weight is 95 and by molecular weight of this magnesium chloride is 95 into 100 will get 100. So all these hardness causing salts first converted into this CaCO3 equivalent terms because it makes calculation is very easy. That's why we can convert it into CaCO3 equivalent terms by using formula is weight of hardness causing salt by molecular weight of hardness causing salt into 100. So let's go temporary hardness. Temporary hardness means only its present calcium, magnesium, bicarbonates in water. So how much amount of hardness present in this? Calcium, magnesium bicarbonate is 50 and calcium bicarbonate is 50. So 50 plus 50 it gives 100 milligrams per liter. This is the temporary hardness present in water. Now permanent hardness. Permanent hardness means is present calcium, magnesium, chloride, sulfates. So in this water it's given according to data calcium chloride, magnesium sulfate, magnesium chloride present in water. So its values are 100, 33.3 and 100. So finally permanent hardness is 233.3 milligrams per liter. So now let's discuss total hardness. How can we calculate total hardness? Temporary hardness plus permanent hardness. So temporary hardness is the 100 and permanent hardness is the 233.3. So when we get total hardness is 333.3 milligrams per liter. So in this class, already we discussed what is the importance of water and which type of impurity is present in water, types of hardness, types of hot water, and what are the units of hardness, and all the hardness causing cells. How can we calculate it? Temporary hardness, total hardness, permanent hardness, and how can we remove temporary hardness and permanent hardness. I hope understand all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.